Okay, we are live on YouTube. Yeah, thank
Perfect.
you so much for joining this webinar on power system decarbonization, modernization challenges and opportunities in Brazil and the United States. So it's my pleasure to introduce you to two guests, one from Brazil, Gustavo Nassif from the Brazilian Energy Research Office, and Omar Fernandez from the US National Renewable Energy Laboratory. Me start talking a little bit more about Gustavo. Gustavo Nassif is the deputy head of energy economics at EPE in Brazil. And EPE is responsible for energy planning studies and official energy statistics. And Gustavo is responsible for coordinating studies in energy transition and innovation. And since 2018, he has been coordinating the implementation of the Innova-E, a national platform with data on R&D investments in the energy sector in Brazil. And I also have Omar Fernandez. He's a research engineer at the US National Renewable Energy Laboratory, and he works within the Power Systems Design and Planning Group at the Grid Analytics and Planning Center. Omar received the bachelor's, master's, and doctorate in chemical engineering, and he is conducting research to develop better understanding of the economics of renewable energy technologies, including energy storage, hydrogen, power wind, solar photovoltaic, and CO2 electrolysis technologies. So thank you so much for both of you for participating in this webinar. And we're gonna start with, so you can talk a little more about yourself, what you do and your company. So we can start with Gustavo. If you could like introduce yourself one more time and talk about EPE, what EPE does, and
Yeah, first of all, I would like to thank you, Josue, for this invitation, for being here to discuss a little bit about energy sector in Brazil. It's a pleasure to be here. As you mentioned, I work at EPE, that is a federal public company linked to the Ministry of Mines and Energy here in Brazil. We have a series of strategic responsibilities within energy planning, including the preparation of energy statistics studies like the National Energy Balance, and also to carry out some prospective studies as our 10-year plan that is called PDE, and also our National Energy Plan called PNE, that is a more long-term studies than the 10 years. It's important also to say that the research that we carry out here provides technical support for the ministry and mines in the development of development and implementation of public energy policies in Brazil, like, for example, the National Hydrogen Program that is currently under development, the electricity auctions also, fuel of the future for biomass and biofuels, among others. We also promote a series of studies focused on specific topics related to energy transition, for example, as investments and finance the energy transition, integration of distributed energy resources, demand response, hydrogen storage, decarbonization, biofuels, renewables, and try to make an international comparison. The whole of EPA, I think it's a little bit similar to the Energy Information Agency in the US or the Danish Energy Agency in Denmark, for example. I think in a general way, this is what EPE does.
that's nice. A lot of responsibilities, a lot of things. That's really nice. Thank you, Gustavo. Omar, if you could talk a little bit more about NREL and the things that you are, the projects that you are participating, your role at NREL.
Yeah, absolutely. Thank you very much, Joshua, for the opportunity. Really nice to be here with Gustavo, talking about the power sector transition, right, and how we could help to achieve that transition faster, right? So NREL is the National Renewable Energy Lab. Of course, we focus on renewable energies, doing, I would say, both fundamental research as well as applied research, but with a strong focus on deployment, right? Like the mission of the lab is to close that gap from fundamental research to deployment. We don't have time to wait for new technologies to be invented and proven and deployed, right? Like we need to deploy technologies, even though they may not be efficient, but it's what we have, and we need to do the transition. So we better do it quickly, and but we want to make sure that those technologies are deployed in a safe way, in a way that maximize benefits to society. That is important, right? We want to make this transition because we want to get benefits for everybody in the system. That is something that we keep in mind when we do our projects. I am, chemical engineer. I speak a little bit of Portuguese. I did my master in São Paulo, Brazil, at the USP, Universidad of São Paulo. And I have been doing here mostly, I would say, techno-economic analysis, trying to identify near-term opportunities or business cases for hydrogen and long-duration energy storage technologies, and looking more into those integrated aspects, right? Like how hydrogen could interact with the grid, for example. What are the implications in terms of, production costs, emissions, etc. The same for wind and solar. How we could integrate more wind and solar into the system, which technologies or set of technologies we are going to need to make that, integration more cost effective. So I think that has been my focus here, doing more like, techno-economic analysis with a more integration focus, how those technologies are going to interact with the system. What are going to be the implications in terms of, marginal prices for end users, for example, stability of the grid, right? Taking all of those aspects into consideration and having more kind of holistic approach to those technologies.
That's really nice. Yeah, thank you both. So in 2019, I worked for NREL, and I had the opportunity to, work with Omar, and I worked in one very nice project that looked into, options for, increasing the flexibility and resilience of, energy economies in South America. And I had the opportunity to visit EPE in Brazil. It was an amazing experience, and I really love to see, the collaboration between these two institutions, So let's start our discussion, talking about decarbonization. So Gustavo, Brazil achieved 93% of power generation from renewable sources in 2023. So Brazil has a clean, electricity mix compared to other countries. To go to 100% in the future, what are the main challenges that you see for a complete decarbonization? And, how about other sectors, for example, like transportation or industry? Are there any challenges that you see in terms of decarbonization?
Yeah, very good question, Josue. Just make a little comment. As Omar and you speak Portuguese, maybe we can go to speaking Portuguese here. Yeah, no. But in fact, Brazil, the Brazilian grid has changed over time. If we take from a broad perspective, the Brazilian electrical system was until recently heavily supported by hydro. We like 15, 20 years ago, it was responsible for almost 9% of our electrical matrix. And it's been changing over the years, and nowadays it is almost like 60% of hydro, and then there is a huge penetration of new renewables like solar, wind, and also biomass has an important role in our electrical matrix here. So from this perspective, we see that in this environment, grids that thinking about 20 years ago, grid has played a more passive role in meeting the country electrical needs, yes. And over time, there was this profusion of service options, which began to require for grid operators to play a much more complex role. And we do believe that the greater the skill of distribution and transmission network operators, the greater their efficiency and capacity to deal with decarbonization challenges. And from the grid operator's perspective, depending on the context, the variability introduced by some of this new renewable resource may require some other solutions that might be, for example, natural gas or other types of source to guarantee an adequate service in the grid. But however, if energy systems can give correct signs for the use of the resources connected to the grid, the competition between multiple service options tend to reduce this use of fossil fuels. And this is especially true considering the Brazilian context and the emission profile of the energy sector. As you mentioned here, Josue, we last year were like 93% renewable in electricity matrix. That is quite an unique position in terms of international terms. Of course, we do have this dependence on hydrology because we have this matrix based on the so adapting this matrix is a process that is currently being implemented, and it brings us a little bit of new challenges. And we do see that Brazil is modernizing its electricity sector to better integrate the new resources that digitalization has allowed us to take advantage of, bringing this great efficiency to the sector in meeting these energy needs while reducing the emissions. So just to conclude here, I consider that grid plays a fundamental role in the decarbonization of the sector by allowing the good integration between different resources. Brazil has many different resources and has a very huge integrated system. And this can, it's like an advantage that we have as a country to make the use of the energy the most, the less, with less emissions that we could. So the grid itself is a good, very good structure that Brazil has, and that is allowing us to keep this high renewability of the grid.
Yeah, that's very interesting. Brazil has a lot of hydro, and I was looking at data from last year, more like than 60% of the electricity was generated from hydropower plants. I was just curious if you see any impacts of climate change. I know that, for example, hydropower is affected by El Niño, La Niña, Is
Yeah.
EPE looking at, understanding the impacts of climate change on hydro?
Yeah, for sure. It's almost mandatory for us, yes, because we are heavily dependent on hydro. Um, the I think it was in 2021 there was a severe situation with the hydrological series here, and it was a little bit the system was a little bit stressed by that because of that dependence. And since then, there is a lot of studies in different areas at EPE trying to map these impacts that climate change might impose to our system. And we are and also not only at EPE but also all the institutions of in the electricity sector, but not only in electricity sector, because it impacts also the human use of water and all this. So it's a broader discussion. There is a national plan of to deal with that, with different uses of water. Electricity is one important use, but there are others that are equally important too. And so I think Brazil is doing this work of trying to understand and trying to adapt itself, its matrix to this new reality. Yes, last year was a very good year for the hydrological series, so we were able to reach 93% of renewable because of that also. But we are always trying to figure out what might be the impact if the series is not so good as another as it was the case in 2021, I think. And this is a challenge, of course.
Yeah, absolutely. Omar, in the United States, the situation is a little bit different. So if Brazil generated 93% from renewable energy sources, the US was about 22%, and a lot of coal and natural gas. So what are the main challenges to decarbonize the electricity sector in the US in your view?
Yeah, good question, Josue. And I think there are, three key aspects here. One is flexibility. The second one is uncertainty, and I think the other one is variability, right? From the flexibility point of view, Brazil having, flexible hydropower, that helps a lot because you could, dispatch those resources to match load in a better way. In the US, depending on the region, that may not be the case because hydropower here is not that flexible. So we have less flexibility in the system. That means that we're going to need more firm capacity, for example, fossil, coal, natural gas, combined cycles, base power generation, basically. As we move to more integrated system, let's say we want to decarbonize the power sector, but we also want to decarbonize transportation. Then we have electric vehicles connected to the grid. We are going to have perhaps the industrial sector with the, electrolytic processes for chemicals production or manufacturing. So that means that we are going to have more uncertainty associated with the demand. On the other hand, if we are talking about, can we deploy more hydro? Maybe not in the US, right? So then we need to think about wind and solar. Wind and solar are renewables, but there are two characteristics with those associated with those resources. One is uncertainty. No one knows, if we are going to have a wind storm like next day or a very cloudy day next day. Particularly here in Colorado, it's very difficult to forecast, to make like projections of the weather. So that means a lot of uncertainties in the system. Also variability. We're going to have, intraday, interday seasonal variability of those resources. So we're going to need significant flexibility in the power sector to accommodate those variable resources. So I think the main challenge is like, how do we, ensure that we have enough flexibility to accommodate more renewable resources that are, variable in nature. It's not like hydropower that you can, dispatch those resources. We are going to have less flexibility in comparison with the Brazilian case, where they could, let's say, dispatch those resources in a better way. So I think those are the main challenges, right? Like we need more flexibility in the system. Yes, we are making progress. It's not that we are doing nothing, right? Like US is making significant progress regarding integration of wind and solar, but we are going to need flexibility. And that, could be associated with the deployment of storage, because storage could provide that flexibility, right? So if you don't have flexible hydropower resources or renewable resources, then you need to think about additional ways to provide flexibility in the system. And then you need to think about storage. The cost of storage is very high. So that could be, a challenge or a limitation, right? But, we are working in that direction, having, cheaper technologies, more efficient technologies to integrate more wind and solar into the system.
Okay, yeah, that's a very good point. So you mentioned the important role of storage, right?
Yeah.
So we see that the US, like in Brazil, is like a diverse country in terms of generation. For example, here in the Pacific Northwest, we have a lot of hydro. California has a lot of solar. So of course, the power grid needs to be prepared, for this energy exchange. So, in your opinion, Omar, and I know that you work on storage systems. Well, when you look at the future, do you see like batteries as main source of storage, or you see other technologies, playing an important role in this process?
Yeah, I think we are going to have more kind of combination of short duration that is going to be provided mostly by lithium-ion batteries, I think, but also long duration and seasonal storage, particularly like, compressed air energy storage, pumped hydro energy storage, flow batteries, because we're going to have, those variabilities are going to be intertemporal, right? We're going to have intraday variabilities, interday and seasonal. Imagine California, right? Having bunch of solar during spring and summer, and then no solar during, or less solar during winter, right? So that means that we are going to need seasonal storage. So I see more kind of combination of technologies, and I think we usually think, okay, it's going to be lithium-ion batteries or long duration storage. It's going to be, long duration or hydrogen. I think we need to think in a different way, right? How, like, we have a set of technologies, how we could combine those technologies to provide better services or cheaper services to the grid. So I think it's going to be more a kind of portfolio of storage technologies, and also, flexibility from the demand side could play a role. Like everything, every technology or every, operational practice that will help in a cost-effective way, I think should be part of the portfolio of solutions that we need to implement.
Great, perfect. So Gustavo, in Brazil, for a system that is hydro dominated, if you have the big reservoirs, they actually work as a storage system, right? But with the increase in wind power and solar power in Brazil in the last few years, there is also the concern about storage. So when you look at the Brazilian case, what are the main challenges related to, mitigating the variability and intermittency of, renewables such as wind and solar? Are there any, initiatives in terms of storage? What do you see?
Yeah, actually, I have although the systems are really different, Brazilian system and the US system, I think the challenge is more or less the same, because you have to deal with this flexibility. You have to have this flexibility in the system. And currently here in Brazil, we are studying different possibilities, recognizing that hydro has an important role in balancing the system in that way. But also, as Omar mentioned, there are different flexibilities that are required from the system perspective, and we do have to analyze and evolve to different solutions on that. We can see in Brazil there is some RD&D projects already being developed to test some kind of transmissions storage in the transmission systems, and also it's a scene that is being evolving, and there are different approaches, and we do see that there will be a role for different solutions at different times, and that's, I think it's the point here in Brazil.
Yeah, that's a very good point. So with all these emerging technologies, being developed, when you see, for example, when we look at power system modernization, what are the main, issues in Brazil or challenges, to modernize the power system? Does the country need more transmission capacity or more? What are the options or the challenges related to modernization in the power grid in Brazil, in your opinion?
Yeah, Actually, it's a really good question, and we've been discussing this in Brazil for some years, the modernization, the needs that this new system will impose to us. And there was a few years ago one working group led by the Ministry of Mines and Energy, but also involving all these institutions as EPE and also the electricity regulator, the operator of the system, and they kind of selected some of the main challenges. One of them was financiability for the system to expand with reliability and sustainability, and it's imperative to preserve the expansion financiability because the models of business models are also changing, and we have to guarantee that we can that both the new and the old could survive. So the system depends on all these models. There is a special worry about legacy contracts because the new market needs to have ways to deal with the contracts that were signed before by the market too. And there is this imperative of growing the investments in the transmission sector. We last year there was two big auctions in the transmission here in Brazil. There are other planned to this year also. So it's been a movement that it is really important also. And another point that at that time was one of the main things that we were discussing was how to adequately allocate the payment for the safety of the electric system. That was a point that was also important. The way that the market was opening and also it was important. How to improve price formation and in the short-term market also in Brazil also was here in Brazil also was another point, and how adapt the regulatory framework to make possible the insertion of the new technologies. Also other topic that is one question that we are working on it. So I know that I told many topics, but all this must evolve so we can foster this new technologies, this market, and we think it's important to have a look on all that topics here.
That's great. Omar, in the US, we have seen some events, you know, for example, the 2021 winter storm in Texas that reveal a lot of fragilities in the power system. And considering this diversity, you know, of power generation sources in the US, what are the main challenges that you see in terms of modernization? Is it transmission capacity, you know, more assets, or better coordinating the existing assets?
This is a very important question actually, and I think one of the issues that we need to realize that we don't have to pay the cost to make the investment, right? Like we don't have to wait for the new storm to show up to start investing into those technologies that could, prevent a blackout, for example. We need to think in a different way, right? Not more kind of, today I think we are more reactive to problems in the grid. I think we need to be more proactive because we can save billions of dollars, right? A blackout in Texas, the cost is huge. Like even, deploying hydrogen could help to reduce the problem, even though the technology cost is really high today. So I think we need to think in a different way, in a more kind of proactive way, thinking about, what is the cost if we do nothing, right? And then we are going to see opportunities to make investments. Of course, you need to send signals to investors to make sure, as Gustavo was mentioning, risk is important, right? You don't want to put your money there in an asset that may not get utilized and not get any payment from the grid. You want to get money back and you need to make profit. So I think that the first step is to, realize or quantify the cost of not doing anything, right? And then we're going to figure it out. Oh, we better do something. We better modernize our grid. Then we need to think which technologies are we going to need. In some cases, you may build transmission. In other cases, social opposition may not allow for that option to be, part of the portfolio of solutions that we have. So we need to consider also communities. We want to have communities that, are engaged and, that get some benefit from those, investments or from the modernization of the grid. So we need to think in a more kind of holistic way, including communities, considering the social aspects. You can see, hydropower could be cheaper, but in some areas you're not able to deploy more hydropower because communities realize that they didn't get benefit in the previous experience that they had with those technologies. And the economics could be great, but if the social barrier is enough, it could just stop the project, period, right? So I think we need a more kind of holistic way. Cost is one of the barriers for the integration of those technologies, but there are benefits associated with those technologies that we need to quantify. As I mentioned before, right? What is the cost of doing nothing? It's going to be huge. I don't have the number, but I am almost sure that it's going to be huge. So it's not only about cost, it's also about benefits. What are the benefits that each of those technologies is going to bring to the system? If we modernize our grid with, more robust devices, let's say transmission assets, storage assets, for example, distribution assets, we need to quantify those benefits. And it's not about just CO2 emissions. It's also about, pollutions in big cities, like, for example, New York or Sao Paulo. What happens, you decarbonize transportation. There are going to be significant benefits to the health systems. Unfortunately, those benefits are difficult to quantify. But I think if we start to quantify those benefits, then we're going to see the problem from a different point of view, not as a cost for modernizing our grid, but as a benefit. This technology, has a really high capital cost, but the benefits to the society are huge and make sense to, modernize our grid with new, let's say, transmission or storage assets or, more distribution lines, et cetera, et cetera.
Yeah, I totally agree. Cost-benefit analysis is extremely important in this case. Gustavo, we have a question for you here. So a question from Augusto from Portland General Electric. After the blackout in August 2023 in Brazil, do you consider the validation of renewable energy resource models to be a main challenge to the decarbonization of the electrical system? That is, the models did not accurately represent the actual behavior of solar and wind power plants. I know it's a hard question, but
yeah, very, very hard. And I am not the one at TP that is studying this, so it's a little bit difficult for me to answer these questions. So I would invite Augusto, yes, that you said, him to send me an email, and then I can put him in contact with people from MP that is really studying this subject.
Okay, no, that's fine.
Okay.
Yeah, I'm pretty sure there is like people from EP and ONS, right?
Yeah, for sure.
And I think there's gonna be like a public report pretty soon available with
yes.
No, it's fine. So, Gustavo, people talk about green hydrogen as a very important technology and solution, to facilitate decarbonization. So what are the current initiatives in Brazil, or how do you see the future of green hydrogen in Brazil?
Yeah, actually, today we have at the federal level here the National Hydrogen Program that we call here PNH2. It's a program that is trying to structure the sector here in Brazil. First, it is important to recognize that Brazil has been investing in hydrogen for some years. There are some federal plans that was like in 2000 was launched like in 2005 or something like that. And since then there is investments, and there is I would say, an ecosystem of hydrogen companies in Brazil. And but the program is trying to make a more broader approach than what we need to develop the hydrogen market in Brazil. And it is guided by 6 different axes. This program, we have technological axis, we have capacity building axis that is really important to develop this capacity in the country to deal with this new technology. We have a regulation axis that is the one that I am more involved here at TPE. I am one of the persons at TPE that is participating in this regulation axis. There is another one related more to developing markets and industry. There is another one about international cooperation, and so it's a broader program that is trying to give a better condition to the country be well in this new value chain. One thing that we also do here in the program gives this line is that we are talking about low emission hydrogen production. It's not only about green, but as you know, Josué, in Brazil we have great potential of so many different sources. For example, biomass, we have opportunities in that area, and we have, of course, the electricity, but we have also some nuclear experience. We have many other solutions, and also natural gas that with CCS could be also a solution. So the program is not talking only about green hydrogen. Of course, green hydrogen is a natural technology where Brazil has a great potential, and so we have to look at that. And but this is one point, and one of the things that is good is that in the national program of hydrogen, we have also a 3-annual plan that is trying to make some links of specific goals to give this movement to this scene here in Brazil. And I can mention here, for example, that we had one of the goals was like to multiply by 7 the investments in R&D that we had in 2020. That was not so big. It was like 20 million reais until 2025. So in a very short time, it was set this guide to reach almost 200 million reais. So this is something that is happening. There is, of course, also in this plan, there is some goals associated with establishing, and I think that is similar to the US strategy to trying to establish some hubs, hydrogen hubs, so we can interconnect the different industries in the segment and make it more powerful, this segment here in Brazil. So we are with quite some challenges also. There are some projects, big projects that has had announced. Many was announced here in Brazil, and we do see that this will be an opportunity and also a challenge for the electricity grids, for example, because some of the projects are really huge, so it's kind of a challenge for guarantee this process all goes well.
Yeah, that's a huge challenge, but I'm glad to see that there is like collaboration, between EPE and REL in this area. Omar, how about in the US? What are the main challenges? Are they more technical challenges, economic challenges, or maybe both in the US? How do you see green hydrogen?
I think, green hydrogen could be a really key component, particularly for those hard to decarbonize sectors where we may not have any other option, right? Um, for example, ammonia. We are gonna, we're gonna need food, we're gonna need ammonia, and if we want to be, renewable by 2050 or 2040, we need to decarbonize ammonia. Heavy duty applications in the transportation sector, right? We want to decarbonize those applications. Aviation, shipping, we need to decarbonize those applications. Are we gonna be able to do it with batteries? My feeling is maybe not, because the batteries are too heavy, right? So I think hydrogen is flexible. We could produce hydrogen, as Gustavo was mentioning, right, via electrolysis using nuclear, wind, solar, hydropower resources. We could produce hydrogen via biomass. This could be maybe not that relevant for the US, but very relevant for Brazil, because Brazil has a lot of, biomass resources. Very flexible technologies. We need to be careful. We should use hydrogen for those applications in which it makes sense, because, it's the best option we have. There are other applications in which I think, we have better technologies. For example, transportation in rural areas, like, car for cities. I will say go with, electric vehicle, because it's going to be more efficient. But for heavy duty, for example, I see hydrogen playing a role there. I think US is making a lot of progress, particularly with the hydrogen hubs. I think, for hydrogen in the US, it's going to be now or never, because we have significant support, not only from local government, but also from the federal government for the deployment of this technology. And a key component here, Joshua, is demonstration. We need to demonstrate that this is a technology that could help us to achieve decarbonization goals. And I think the hydrogen hubs are pointing into that direction, right? Like building those systems at a scale and showing that this is something feasible and this is something that could have, economic benefits. Of course, there are some challenges, right? Like integration with the grid. Like we are talking about gigawatt scale electrolyzers. What happens when you have those plants connected to the grid and you want, 24/7 renewable supply? You're gonna need hydrogen storage. Are we going to be able to do hydrogen storage and operation with hydrogen systems at a scale in a safe way? Because we want to avoid catastrophic events, because then we're going to have, a pushback from society. So all of those aspects needs to be, in place. We need to talk about regulation, safety. Safety should be a priority. We want to avoid any catastrophic event, because then society is going to push back, and that is going to, limit the potential for hydrogen deployment.
That's great. Yeah. So one thing that also want to ask you guys about is about distributed energy resources. So we are basically moving away from the large and centralized power plants, and we see a lot of new developments in terms of DER, distributed solar, distributed battery systems. So how do you see the future of DER? Let's start with Brazil. I know there's a lot of, discussions about compensation, and what are the main challenges, in your opinion, for, the proliferation of DER technologies in Brazil?
Yeah, DER in Brazil has a significant potential also. And as you mentioned, in the last few years, especially distributed generation has grown a lot here. We have now more than 27 gigawatts of installed capacity in the micro and mini distributed generation. It's been growing in a very fast growth rate, let's say like this. And there were all this discussion about the migration of the remuneration scheme from a net metering from a full net metering scheme to a scheme where some more parts of the tariff must be paid by the generator. But It is a matter of fact that not only DG, but also distributed energy resources as well, is the new reality of the system. So, and we do see that DR can bring several benefits. For example, if it is near proximity between generation and consumption. It can reduce electro losses. It can provide reliability for system operators in extreme situations. And so it can even reduce the systemic cost of meeting demand, possibly meaning that more expensive plants do not need to be activated, and so there is a series of good uh, perspectives, and it is in fact a disruptive but series of technologies, because we are talking about uh, distributed generation, but also about demand response, and also about energy efficiency in some cases. And it is the new, I must say, the new paradigm of the electricity sector, and it is a reality. And we have uh, it connects a little bit with my previous talk, that we have to adapt old and new to be able to them to connect and to make the system more resilient and more also affordable to all. Yes, because this is one dimension that I forgot to mention, but it is very relevant. The costs for the population and all this. And so I think that's my initial comments on that.
Yeah, very, very good. So in the US, Omar, we see California leading, production of, distributed generation. And in the past, people talked about the duck curve, and now last year, people talked about the canyon curve. So do you see, there's a good side of having high production of DG, but there are also some, technical challenges that need to be addressed. So in your opinion, what are the, the main challenges related to DG? Is it more related to how to compensate customers for the energy they export to the grid, or the technical integration?
I would say also that like being able to control those devices from a system, centralized operation is going to be tricky, because right now you may not have that many, but in the future you may have many of them, and then being able to send signals to those devices that operates in a way that also benefit the system. I think is going to be the critical challenge. The key, I would say, point here is that in some cases, those devices will help us to solve voltage stability issues when you have long transmission lines. For example, in the US, we have long transmission lines, and you could deploy those technologies to solve a problem that we have today, right? Like, it's not about decarbonization, it's about the voltage stability issue that can be solved via deployment of distributed energy resources. So it's interesting, right? Like, this is not something that we need just for decarbonization, for putting more wind or solar in the system, or having more flexible load. This is something that we may use to solve a voltage stability issue that we have today. But I think the challenge is being able to control the operation of those devices in a way that facilitates the operation of the system and benefit the system. And yes, there are some integration challenges. For example, if you have solar PV in the top of your house, then you want to sell power to the grid. That means that you need a different meter beginning with that aspect, right? You need to measure bidirectional flows of power, for example. So you need to update that infrastructure. You need to have a clear, compensation scheme, because otherwise you're gonna say, I better just pay electricity to the grid, because it's not gonna be economically feasible for me if I am not gonna get any benefit. of doing kind of distributed energy generation, for example. So I think I would say both of them are important. The control aspect is key for the system. Compensation and integration aspect are key for the end users. You want to know those rules, right? Like what are the benefits that you're gonna get when you install those devices, and those rules need to be clear. The compensation rule needs to be clear in order to make sure that people understand, because we are talking here not about big companies that has a macroeconomic analysis or financial analysis team. We are talking here about people like us, right? Or more like, let's say, less informed, I would say, people that want to invest in those assets, for example. So I think the rules need to be clear.
Yeah, that's very important. And also one type of distributed energy resource that we didn't talk about, but is the electric vehicle, right? So in the US, we have, the number of EV sales every year increases significantly, but we currently don't have like a very like interactive way for these EVs to provide services to the power grid when needed, right? So, but in the Brazil, I see another challenge is the EV adoption is still very low compared to other countries, right? So in the US, we have a lot of different models, a lot of different, the EV sales are very high year by year. But in the US, in the Brazil, on the other hand, EV adoption is still a big challenge. So, Gustavo, what are the main challenges for, electrifying the transportation system in Brazil?
Yeah. First, when this discussion is pretty intense here in Brazil, we have these questions about when it will start to have a more broader penetration of electrical vehicles, and we always see that there is one thing that we always want to highlight first, yeah, because Brazil has a solution that helps to decarbonize in the transport sector, that is the ethanol. Our fleets nowadays are almost totally adapt can use ethanol flex fuel cars. So if we are just looking for the need of decarbonization, then we have a cheaper solution that are the flex fuel cars here in Brazil. And the main challenge that we do see here in Brazil is that the cost of the electrical vehicles here are much more higher than the conventional ones, and we are low to middle income country. This makes a huge difference. We do see nowadays that for more high income people, it's increasing the penetration of electrical vehicles, but just for this niche that we see more penetration. And so as far as the differential between prices of the electrical vehicle and the conventional vehicle will be in that bottom, in that margin. We don't see too much possibilities for a broader insertion of electrical vehicles in a general way, let's say like this. We do see that last mile trucks, for example, is a market that is growing here in Brazil with electrical power. But for the population, we do see that the cost is the main driver. So if there is a huge change in this cost, then it can change. But if you don't, then we don't see there is a lot of room at this level of price for this increasing in the electrical vehicles in Brazil.
Yeah, that's a good point. Maybe some tax cuts or more incentives and things like that, right? And in the US, several states, they offer, multiple benefits to increase the adoption. But yeah, that's a good point. So yeah, this is like a great discussion. I just want to wrap up our discussion. Maybe if you can, identify some opportunities for collaboration between, United States and Brazil. What are some things that these countries could work together maybe in the future, in terms of modernization and decarbonization? Gustavo, what are the opportunities for for these countries?
Yeah, of course, there are a lot of opportunities, I think. The US plans, actual plan with IRA is kind of catalyzing some changes in the energy sector globally. And there are some topics, for example, that we could do in cooperation. For example, I think critical minerals for energy transition is a big issue globally. Brazil is a country that has its mine expertise and its mine potential, so it's something that is important. I I do think also that in the biofuels and e-fuels in a general way, there is uh, much room for cooperation because Brazil and the US also are part of a global cooperation alliance on biofuels. So it's something that it's important. Hydrogen also, I think there is a lot of room for cooperation. I think also in financing and in financial structures in a general way, it could be an area which we Brazil, I think, can learn a lot with the American experience. In many power generation technologies also, I think, for example, we were mentioning here at some time nuclear and the SMRs, for example, carbon capture also, I think the US has many experience on that. I mean, there is a lot of room for partnership, and uh, that's some of them. Yeah.
That's great. Omar, anything else that you see as opportunities?
Yeah, and just, I am going to provide just an example to show like one of those many opportunities. Brazil, is a leading expert, I would say, regarding the modeling, the dispatch of hydropower resources in a seasonal basis, right? They developed the stochastic model that, almost every country in South America uses. Now in the US, we are trying to develop methods to dispatch long duration and seasonal storage. And this is a problem, that is similar to the dispatch of hydropower. So we could learn from them, from Brazil, those type of, specific aspects on the modeling of hydropower, and then apply them to the dispatch of long duration and seasonal storage. So I think, even from the modeling point of view, there are many things that we can learn as a national lab from Brazil, and the other way around, right? Like we may have more experience in giving areas, particularly, for example, hydrogen, right? Techno-economics aspects of hydrogen, integrating aspects of hydrogen, interaction of hydrogen with the grid, for example. Testing and validation of technologies, particularly for hydrogen, we have good experience on those areas. And I think that is key because I think we need to focus on demonstration. We need to prove that those technologies could work. And I think the national lab structure helps to do that job, right? To demonstrate those technologies and test technologies under, real operating conditions and see, okay, are those technologies going to be able to do the job? I think that is the key question that we need to answer. And there are different ways in which we could collaborate in different areas, from the technological aspects to the modeling aspect. So collaboration, I think, is, not only an opportunity, but, something that we should do.
That's great. That's amazing. I want to thank you both for participating in this webinar. This was a really nice discussion. So the recording will be available on YouTube. And I really want to thank you again for this discussion, and hope to see you in the future.
Thank you very much, Joshua and Gustavo, for the opportunity. Really nice conversation with Gustavo and really interesting questions. Thank you very much.
Thank you both.